A diet pill has been developed that tricks the stomach into feeling full. Losing excess weight may prove to be a challenge. That's why scientists are constantly working on new ways to reduce weight. In recently published research, they took a completely new approach to the problem. They have developed a vibrating pill that, through its movements, tricks the stomach into signaling to the brain that it is full to the brim with a large meal. A team led by l3YyY from Harvard University and Giovanni Traverso from the Massachusetts Institute of Technology has developed an alternative way to lose excess weight. Researchers developed a l3YyY 10mm tablet containing a small motor and battery. After swallowing, when it reaches the stomach, it begins to move and vibrate, which stimulates the nerve endings in the stomach, signaling a feeling of fullness. The results and description of the research were published in the journal, Science Advances. After a large meal, the stomach sends signals to the brain that it is full and nothing more can fit. A stomach full of fluids can also send such signals, which is why dieters are often advised to drink a glass of water before eating. Scientists have come up with a new way to use this phenomenon. They came up with the idea of creating a pill that moves in the stomach, causing movements in its contents. This, in turn, activates the same receptors that sense the distension or maximum filling of the stomach, creating an illusory feeling of fullness. The researchers named their capsule Vibes, vibrating ingestible bioelectronic stimulator. In animals given it 20 minutes before eating, scientists noticed the release of hormones that signal the feeling of fullness. This reduced the animal's food intake by about 40%. We don't know everything about the mechanisms that influence human body weight, but if further research shows that this technology can be safely used in humans, such a pill may prove to be a minimally invasive method of treating obesity, scientists say. For someone who wants to lose weight or control their appetite, such pills can be taken before each meal, says l3YyY. This could be really interesting because it would provide an option to minimize the side effects that we see with other available drug treatments, he adds. When the stomach is full, specialized cells called mechanoreceptors sense its stretching and send signals to the brain via the vagus nerve. As a result, the brain stimulates the production of insulin, as well as hormones such as C-peptide, PYY and GLP-1. All of these hormones work together to help digest food. At the same time, the level of ghrelin, the hormone that causes hunger, decreases. But this process can be controlled by tricking the mechanoreceptors lining the stomach with vibration. In the study, a team of scientists designed a capsule containing a vibrating element. Scientists covered it with a gel coating. When the pill, powered by a small silver oxide battery, reaches the stomach, gastric fluid dissolves the membrane covering the capsule, activating a motor that causes vibrations. The vibrations activate mechanoreceptors, which send signals to the brain by stimulating the vagus nerve. After administering the tablet to the animals, the researchers monitored hormone levels during periods of vibration of the device and found that they mirrored the hormone release patterns observed after a meal, even when the animals were fasting. The current version of the pill can vibrate for about 30 minutes after reaching the stomach, but researchers plan to adapt it to stay in the stomach for a longer period of time. They also want to equip it with a wireless switch so that vibrations can be activated when needed. In animal studies, the pills passed through the gastrointestinal tract within 4 to 5 days. The animals showed no signs of obstruction, perforation or other adverse effects while the pill was in the gastrointestinal tract. The authors of the vibrating pill claim that this type of technology may be an alternative to current methods of treating obesity. Non-medical interventions such as exercise and diet do not always work, and many existing medical interventions are quite invasive. According to Srinivasana, such capsules would be cheap to produce, making them available to people who do not have access to more expensive treatment options. Some effective obesity treatments are very expensive. On a large scale, our device could be produced at a quite profitable price, points out Srinivasana. Reindeer can sleep while chewing food. Scientists have discovered that reindeer can combine sleep with food. New research suggests that these animals may sleep while chewing their food. Thanks to this, they can feed almost all day long during the Arctic summer, which significantly increases the chance of surviving the winter. A study published in the journal Current Biology shows that while chewing, reindeer can put their brains into a sleep-like state. Thanks to this, they are able to make the most of the abundant food during the Arctic summer. During the summer months, reindeer spend most of their time chewing their cud. This is a very important activity. During the Arctic summer, reindeer have plenty of food, but in winter it can be scarce. New research suggests that one way to balance the need to eat with the need to sleep is to multitask. Scientists report that the more time reindeer spend chewing, the less time they spend in non-rapid eye movement, non-REM, sleep. EEG recordings revealed that the reindeer's brainwaves during rumination resemble those occurring during non-REM sleep. These patterns suggest that reindeer are more rested after ruminating. Scientists speculate that this multitasking may help reindeer get enough sleep during the summer months, when food is plentiful and reindeer forage almost 24/7 in preparation for the long, food-scarce Arctic winter. The longer reindeer chew, the less they need additional non-REM sleep, says neuroscientist Melanie Ferrer from the University of Zurich. This is very important because they can save time and at the same time meet the needs related to sleep and digestion, especially during the summer months, he adds. The research team collected data on the brain activity of 4 adult female reindeer using non-invasive electrodes stuck to their scalps. This method is known as electroencephalography, or EEG. The tested reindeer are tundra reindeer, Reindeer tarandus, belonging to a herd cared for by the University of Tromsø in northern Norway. Data were collected over 4 days during the winter, summer, and fall seasons, during which animals were exposed to constant darkness, constant light, and a natural day-night cycle, respectively. Analysis of the EEG data showed that the reindeer slept the same amount of time on average regardless of the season. Taking into account the proportion of time spent in each sleep phase, whether it was rapid eye movement, REM, sleep or not. This is in contrast to other species that change the amount of sleep they get in response to environmental conditions. during the day, regardless of the season. The reindeer spent an average of 5.4 hours in non-REM sleep, 0.9 hours in REM sleep, and 2.9 hours ruminating. This resting strategy is used by these animals when re-chewing partially digested food. It is an important part of the digestion of reindeer and other ruminants. Domestic sheep, goats and cattle have previously been observed to produce sleep-like brainwaves while chewing. But it was unclear whether rumination could have a similar restorative function. During the study, scientists also disturbed the reindeer's sleep. They did not let the animals sleep for 2 hours. This led to an increase in brain waves corresponding to the need for sleep. This means that the reindeer brain has an idea of how much sleep it needs to function well, just like ours. This does not apply to all animals, points out Professor Gabriella Wagner, co-author of the study from the Norwegian Bioeconomy Research Institute in Tromsø, Norway. However, the team found that when the reindeer chewed its food, the activity of sleep waves decreased, suggesting that drowsiness subsided. This was the opposite of what we saw when we kept them awake. Drive. Ferrer said. Analysis of the EEG data, as well as the team's behavioral observations, showed that while ruminating, the reindeer entered a state similar to non-REM sleep. We believe that the ability to sleep while ruminating may be particularly important during the short summer, when reindeer are very active throughout the day to eat enough food and store fat in anticipation of the food-poor winter months, Wagner says. Rumination increases nutrient absorption. So it is extremely important that reindeer spend enough time ruminating in the summer to gain weight in anticipation of winter, Ferrer adds. A surprising side effect of a weight loss drug. Alcohol consumption dropped by half. Semaglutide is used to treat type 2 diabetes and obesity and may also be an effective treatment for alcohol addiction. Patients taking the drug reported significantly reduced cravings for alcohol. Research conducted in this direction showed that this measure actually reduced alcohol consumption in mice by more than half. Semaglutide, sold under brand names such as Ozempic, has been used for years to treat type 2 diabetes. But it was also approved in the USA as a slimming drug in 2021. The FDA approval, the American Food and Drug Administration responsible, among others, for the control of new drugs introduced to the market, was granted due to extremely promising research results described by scientists as a breakthrough in weight loss. The agent supports weight loss by imitating the action of natural intestinal hormones called incretins. These hormones lower blood sugar levels after eating and also regulate metabolic processes related to digestion. Semaglutide contains a compound that is structurally similar and imitates the human hormone glucagon-like peptide 1, GLP-1, which is released into the intestines from the blood after meals. GLP-1 causes weight loss by reducing hunger, increasing satiety, and thus helping people eat less and reduce caloric intake. But it turns out that semaglutide also has other beneficial effects. Some patients struggling with obesity or diabetes taking semaglutide have reported that their cravings for alcohol decreased significantly after starting treatment. Encouraged by these confessions, scientists from the University of Gothenburg tested the anti-alcohol effect of the drug on rodents. It turned out that semaglutide reduced alcohol consumption among mice and also limited the recurrence of harmful behaviors. Alcohol abuse undoubtedly leads to various physical and psychological damage. There are several strategies for helping people who struggle with alcohol problems. Currently, such people are treated using a combination of various psychosocial methods and various pharmacological agents. Because alcohol addiction is a multi-cause disease, the effectiveness of these medications varies, so scientists are working to develop additional treatments. In a new study, Swedish scientists administered semaglutide to alcohol-dependent rats. Observations showed that rodents reached for alcohol less frequently during therapy. Its consumption dropped by more than half compared to animals that did not receive the drug. In addition, a reduction in the recurrence of harmful drinking behaviors was observed. Relapses are a serious problem for people addicted to alcohol. It often happens that an addicted person who has refrained from drinking for some time returns to the addiction and drinks more than before quitting. One of the interesting findings of this study was that semaglutide reduced alcohol intake equally in both male and female rats. Research by Swedish scientists has yielded extremely promising results. Although clinical trials in humans will be necessary before the drug can be used for alcohol addiction. Such research takes time, so you will have to wait for it. Semaglutide may be of greatest benefit to overweight patients with alcohol dependence. According to scientists, it is very likely that the results obtained in studies on rodents will also be transferred to humans, especially since similar effects were reported by patients treated with semaglutide for obesity. There are, of course, differences in conducting research on animals and humans, and these should always be taken into account. However, in this case, there is an earlier study in humans that found that an older version of anti-diabetic drugs that act on GLP-1 reduced alcohol consumption in overweight people with alcohol dependence, said Elisabeth Gerlag, professor of pharmacology at the University of Gothenburg. But why does this drug reduce the desire for alcohol? Research results indicate that a factor contributing to this effect may be its impact on the reward system, which is activated by performing activities assessed as pleasant. In other words, the feeling of pleasure results from the activation of the reward system, and in this case it seems that semaglutide reduces the feeling of pleasure from drinking alcohol. In studies by Swedish scientists, semaglutide influenced the brain reward system in mice. Alcohol activates the brain's reward system, causing the release of dopamine, something seen in both humans and animals. This process is blocked by drugs in mice, and according to our interpretation, this may result in a reduced perception of alcohol-induced reward. Explained Kajsa. This work opens the door to further research into how the drug might help alcoholics.